Wash your hands, men. Alright, welcome back. We're going to go back over Ionic Bondss. This is a review. If you do not need help with this, please move on and watch the next video. I've decided to talk in a British accent because I just think you'll pay more attention, and you're probably tired of my voice by now. So, moving on, we'll just talk in a British accent. So, Ionic Bondss. Let's say we take Na, sodium, Na, off the periodic table. It has no charge at all. It is neutral. That means the protons equal the electrons. So right off the periodic table, it does not have a charge. But as soon as it gains or loses an electron, it then will have a charge and it will become an ion. So an ion just equals a charged particle, just because it's gained or lost an electron. Alright, let's look at the classic example, but first, before I forget, let me give you more information on ionic. You should write that ionic means gain or lose electrons. If it's ionic, it has to be a bond between a metal and a non-metal. Yep. Which means one will be a positive and one will be a negative, which is how they have such a very strong bond. The opposite charges attract. Now, NaCl, sodium chloride. You need to look at your periodic table, and you need to not be lazy. Get it out of your bag. It should be on page 39. Get out your periodic table and find sodium. I think I'm starting to talk like an Aussie. So, sodium, right here, sodium is in group 1, and that tells me it's got one valence electron. So let's draw that. Okay, now we've got to find chlorine, which is over here in group 17. And that means it has 7 valence electrons. So let's draw those. 1, 2, 3, 4, 5, 6, 7. Okay, sodium is trying to get to its happy state. So it's going to do everything it can to get rid of this dude here, this electron. And it's going to try to give it away to someone that needs it. So this electron is going to go and bond with this chlorine. So let me just draw in an X there so you know exactly where it bonds. And now both are happy. They're going to stay together because they've just developed a bond. Now, Na has lost a negative. Na has lost a negative. So Na becomes more positive. And this is how you officially write it. And now let's do Cl, and we are going to go ahead and draw its new found valence electrons, which will be a total of 8, which means it's satisfied the octet rule, and it is very happy. So, since chlorine has gained an extra electron, the neutral balance is upset, and now this is going to be a negative. Okay, so let's talk about naming these ions. First of all, let's look at this here. The positive, or the cation, will always come first. So in this case, sodium is the positive there, sodium. And then the second word is going to be a negative, and it's going to be called chloride. Everything that's negative, everything in an ionic bond that is negative is going to end in "ide." So IDE just means negative. One last important thing for me to tell you about ionic bonds is they do not form molecules. Ionic bonds do not form molecules. So that goes back to crystal lattices and how they're held together and things like that. We'd have to dive way into chemistry for you to completely understand, so you just got to take my word for it. Have a good one.